Alright, welcome back everyone to the channel. Today we're diving deep into building a fun and interactive web application. Obviously an Avengers-themed word guessing game using Flask. We've already done this to build a console app and progressed to build a GUI, graphical user interface app. We'll be building on all of this. So we'll cover everything from importing the modular game logic that we worked on in the previous videos, check them out, all the way to deploying our app online. We also talked about a few ways you can deploy your app, about 20 different ways you can deploy it. So check out that video as well. So this project is going to demonstrate key Flask concepts like routing, template rendering, handling user input, and so on and so forth. We've also have a video that talks about this in detail, so check those out please. But we will also explore best practices like code organization and explore deployment options for sharing your creation to the world at large. Okay, so a quick recap on how we got here. Starting from version 1, version 2, and the GUI. So opening Visual Studio Code, in the folder we can see the GUI. We also got version 2 and the initial version which was not modularized. So let's discard that and take a look at version 2 as well as the GUI side by side. So a few updates we have to do to modularize this would be taking advantage of the functions that has already been created in version 2 and importing it into version 3 simply by typing the import statement and providing the name of the file. That gives us access to all the functions within our version 2 file. But if we need just particular functions to pick and choose, we can use different syntax from that file. We need to import the particular functions, so we get to pick and choose which ones we want. That way, we don't have to make changes in multiple locations. Maintenance is easy, and it also helps us to make our code look more concise in the new GUI. So again, updates are made in one section. We can get rid of the extra functions that we had to rewrite because they're pretty much the same thing. So that takes care of refactoring, and we can go ahead and close that out and try testing it out to make sure that our program actually still works, our code actually is still functional. So let's close that and start with version 2. Check it out. If we want it, select a difficulty level. Let's start with easy and guess our way through this. Okay, so we got Ant-Man, and we also get to guess a space or a letter. Now let's try it with the GUI. The GUI is also asking for the difficulty level, which it pulled out from the version 2 file. So again, this pops up behind. Let's bring it up to the front, and this is what our GUI looks like. We're going to fix this up a little bit more in a minute, so let's guess our way through this. Looks like it's still Ant-Man. So just to make sure that the random is really working, let's run this again and see what we get. So once again, we still got everything behind. So let's get our GUI window from the back. There you go. Okay, so this time around we got something different, guessing A, N, again those popular letters. Oops, there's no T. and F, so definitely you already know that should be Falcon. Just like that, we guessed it, and that's how we go ahead and modularize our code. So before we get into the Flask web app, which is going to reside in a virtual environment, let's go ahead and enhance our GUI. It looks very bland, so let's modernize it by using Customtkinter. Tkinter stands for Toolkit Interface. So before using that, we need to import it. Make sure that, or rather install it. Make sure that we install it correctly, making sure the spelling is correct. Once it has been completely installed, then we can go ahead and import it. Tkinter comes pre-built with Python, but custom Tkinter needs to be installed separately. So we're installing it into the virtual environment which we created earlier. So we created a Avengers game folder, created a virtual environment in there, and now we're going to create a new Python file, Avengers Assemble GUI version 2, which is going to be based on custom Tkinter. So we need to import custom Tkinter, and there will be a modern look you see at the end of this video or at the end of this section. We also import the functions that we modularized in the previous version of our Avengers Assemble code, which we just looked at. After that, we need to build a few functions ourselves, starting with the play game function. This is going to be the main loop of the game. It's going to take the root window, and the rest of the functions going to be similar to what we looked at before. So in addition to the root window, we're going to get the chosen word and the maximum number of guesses as the arguments. So it's going to create a GUI, or rather GUI elements, which we need to set up. But to get started, we need to initialize some variables to keep track of our guesses. So the correct guesses, the incorrect guesses, or good and bad guesses, if you want to call them those, and so on and so forth. Excuse me there. And once we're done with that, we create those custom widgets. Again, labels, like we discussed earlier. A word label is going to display the current state of the word. So we're going to need to call on custom Tkinter to give us a CTK label. Make sure that it's going to be appended to our root window. It's going to display a text. That text is going to come from the imported module, the imported function, which is the display word function. So we don't have to redo it. And just to make sure that the user interface is neat, we give it a particular type of font as well as the size of the font. Once we created that label, we need to append it to our root window using a grid layout. We looked at the pack layout earlier. This time around, let's do a grid layout, which pretty much just looks at rows and columns. So we're going to separate our window into rows and columns. So let's start by placing this label on row 1, column 0. Again, remember the rows and columns start from 0. But we're going to span a few rows. So span a few columns in this case. So it's going to take 3 columns. It's going to take the entire top. And give it some spacing on the y-axis. So let's say 20 padding. Now we're done with the label. We also need to be able to get the player to enter their guess. So the player's guess is going to be guess entry. So again, instead of typing custom Tkinter all the time, we can just give it an alias. So with that alias CTK, we're going to use CTK whenever we need to create a widget or do anything on custom Tkinter. So create that entry, place it in the window, give it a placeholder text, and then append it to our grid, particular column, this time around the second row, still the same column, and everything should be good as long as we space it around so it's not congested. Next, we need some kind of a button. That button is going to trigger the next function when it gets clicked. So for now, let's not focus on the next function. Let's focus on the button and give it the text. The text is going to be guessed. So you enter your letter and then you click on the button. It's going to check all whatnot. Also, after creating a button, we get to add it to the window in a particular location based on the row and column that we entered 2 and 1. Again, more spacing and so on. So the command button, we're going to take care of that shortly, but let's jump into the next function, which is the make guess function. Okay, this make guess function, like we just said, is tied to that guess button. So it's actually what happens when the user clicks on the guess button. It's going to get the user's guess, validates it, check for updates in the game state accordingly, and so on and so forth. So let's work on that. So some of the attributes, or rather the arguments, would be, again, the word, the guesses, also the good, bad guesses, the maximum guesses, our actual word level, and also the entry that the user had for their letter. Once those have been placed, we then go ahead and, double check. First, we get the user's input, set it to an uppercase, so everything is normal, or should I say everything is streamlined. And then we clear out the entry in that field so that we don't get to append it each time. Once that is done, the next step would be, picking a random number. So we probably have to, before we get to that, let's see. We want to make sure that, their guess is actually a letter or a space. If they enter anything else, then we need to give them some nice feedback. So we're going to need a status or status label. So that status label is where we're always going to give them some feedback on, what the status quo is. So status label, again, we're going to create that later on. But for now, let's just understand that there's going to be somewhere where we're going to save our messages. Once that is done, if they are not complying and not entering a single letter or a space, then we just return them back until they do so. But if it is a letter that has already been guessed, then we need to also tell them, hey, you already guessed that letter, and then also return them and give them an opportunity to, correct that mistake. Otherwise, we go ahead and take that letter and add it to our guesses. Remember, we created these guesses, this guesses variable earlier, which is a set. So there are not going to be any duplicates. All right, so once a guess has been valid or validated, we now go ahead and check if it is good or bad. So if the guess is in our word that has been randomly selected already, then we go ahead and update the number of good guesses and say, hey, +1. Otherwise, we do the reverse. So once we've updated it, we also need to get some kind of a message. We need that user interface and user experience to be friendly for our users. So give them some feedback and say, hey, your guess is good. It is in the word. Otherwise, your guess is bad. It is not in the word. And then we update the bad guesses as well. All right. So moving along, once we have been able to validate and also check if it's good or bad, we then need to proceed to display the word. So the word display again is going to be Leveraging the modularized version 2 code that we had, I'm just going to pull that in there, and then that's good. And the word label, which we created earlier, needs to get updated, and it's going to get updated with this word display that we have gotten from the random code in version 2. Awesome. So I think that's looking good so far. We've been able to get the guessing of the word, and then checking also, we need to know if we actually won or lost, or we are still playing the game. So again, similar to what we did in version 2, we check if all the letters in the guesses actually match all the letters in our word. Then we go ahead and update that same status, which we're going to create later on. So give them some kind of a message, and hey, congratulations, you rock. And then give them the actual Avenger word or Avenger hero, which they already guessed anyway. But just print it out to be nice. All right. So now we go ahead and make sure that we disable the entry field as well as the button, because you don't want them entering any more letters since they've already completed the task. They've already guessed the word. But there's another option for them to fail if the number of bad guesses is equal to the number of maximum guesses that they can have. Then unfortunately, we're going to output the status and say, sorry, game over, you lost, unfortunately, and encourage them to play again or something like that. And then we also go ahead and disable those entry fields and buttons. Again, make sure that your output is clean, friendly, spaced out, not bunched up, and that's it. So, but remember, the make guesses only happens after that button is clicked. So we need to address how this takes place, and it's simple. We just create a command, but we need to use a lambda function because we have multiple arguments in here. So again, our make guesses is a function that's going to be executed. So we pass in all those variables or arguments that are coming from the play game function per se, and then it gets passed on to the make guess function, and that should be Gucci. Awesome. So we'll make sure that the syntax is good, everything is good. We're missing something here. Let's double check that. Yeah, I see the make guesses is dimmed out on line 22, which means there's a problem. And let's see if we can identify this issue. So if we collapse that, it looks like something down here needs to give, yeah. So out there, yeah, let's go ahead and make sure we finish it. We'll come back to that. But yeah, to modularize our code again, that is, each time that we run this directly, it's going to understand that, hey, the main function or the underscore main is the name. So it's going to go ahead and do the main function for us. Otherwise, it's going to think we're importing it, which is not the case. So a few things that we need to do in our main block of the code. We need to provide some kind of appearance mode as well as a color theme, which makes it nice. It's going to give us an appealing user interface. So again, adding those to our theme and then creating a root element, we should be able to go ahead and build the rest of our code that way. Let's see here. Okay, so again, provide a title for our window. We create a window and call it root. Provide some kind of a geometry, the length, or sorry, the width and height. And then, welcome the users to our game, very nicely. Everybody needs to be welcomed, feeling good. Add that to the window, the root main window, which is the root, and provide a text, something similar to the title, Marvel Avengers Assemble word game, so that you're at the right place. And as well, provide a font and size, maybe make it bold as well, so that it stands out from the rest of the content. And once again, we add it to our grid. The grid should be in the root, and the row should be the very first one. The column is the very first one as well. And then make sure it spans the entire width so that it's centralized per se. Provide some kind of spacing as well using the padding on the y-axis. So once again, we have everything looking good. Let's see if we can double check and find that error. Difficulty is something we need to work on next. So we did not import the difficulty from version 2. So let's try to see if we can add some kind of a difficulty level we're going to use radio buttons. So in order for us to use a radio button, we need to first of all have a string variable which is going to bind the values in our radio button to an actual variable. And this time it's going to be a string and not, well, it could be an integer, it could be a boolean, but let's keep it a string to make it easy. So, it's user friendly. The syntax doesn't look right. Yeah, so first we need to make sure that, we're getting a ctk string var, and then give it a default value, making sure that each time you open it, it's going to default to an easy. Make sure that's good. Yep, make sure that it defaults to an easy difficulty. And then now we create our radio button. So we're going to have 3 radio buttons. Radio buttons are better because you can select one and not the other. It's mutually exclusive. Rather than having a drop down, you have to click twice, and that's too much going on. So again, create our easy radio button, medium radio button, hard radio button. Each one of them has a different text, either easy, medium, or hard. Each of them also has different instructions, a maximum of 3 wrong guesses, 5 wrong guesses, or 7 wrong guesses. And the string variable is bound, or the difficulty variable is bound to our variable, as well as the value gets passed on. Once we've created those 3 radio buttons, we need to add them to the grid. So what row do we add them to? I think row 4, because the status label is going to go to row 3 for now. So let's reserve row 3 for that. And then we have our easy, medium, and hard radio buttons on row 4. Provide some paddings as well, and then we're good. So make sure that we're adding all 3 buttons to our window, and then aligning them accordingly by column to make sure that they are not overwritten on top of each other. So far, so good. So we've been able to create our difficulty radio buttons. Now we can move on to the next step. So once we've done that, we need to define a function that starts a game, because once you select the radio button, you're going to click on a start button, which is going to start the game for us. So what does the start button do? It gets that particular difficulty that was selected. So we get a variable to hold that value. So it's going to get that value from the difficulty variable that we created, that is a binding value some kind of way. And then based on the difficulty level, we can now set the number of guesses or the maximum number of guesses. So if the difficulty level is easy, let's set it to 7. Otherwise, if it's medium, let's set it to 5. Else, let's set it to 3. And so we've got our difficulty level taken care of using the graphical user interface rather than using the command line. Once we do that, we're going to need our Avengers. So I'm going to cheat here and just copy the list of Avengers from our version 2. Once we get that, we can now go ahead and use that random word to be able to get what value it is. So our status label, we also want to be able to configure it to make sure that initially it is blank. There's no status updates at the beginning of the game. Once you start the game, remember we're working on the start game function. Now we want our word to come from the get random word function, which is imported from our version 2. So we don't have to redo it. And once all of that is set, we've gotten our Avengers list. We've gotten our label cleared out. We've also gotten our word randomly generated. We can now play the game. And then we should be good to go. So start button can now be appended or created first, provided with the text, and make sure that the command is going to point us to the start game, and we should be good. So again, the command in this case is not using a lambda function because there's no arguments for the start game. So it's just a simple one. Now we don't want to forget adding the start button to the grid. Otherwise, we won't see any button. So let's go ahead and add the start button to our layout using the grid provided with the column. And then we should be good to go. So yeah, column span it across 3 columns. Yeah, and then we should be good. Awesome. So again, one thing that we used quite a bit was the status label, but we haven't created it yet. So once again, we use CTK, which stands for Customtkinter, since we have an alias. Get that label, attach it to the root, make sure that it's blank to begin with, and then add it to our grid. So it's going to be at row 3, which we had reserved earlier for it, since we didn't put anything on row 3. And add some padding, and that's fine. Yep, with that, we can now call on our window to run a main loop, and we should be good to go. So let's go back and see what our issues are. This might not probably run because we have typed in quite a lot without testing or debugging it each step of the way. That's fine, but we're going to get through this. So the first error here, again, taking care of that comma. That's why we had the make guess grayed out earlier. So we're good now. But they still have the status label underlined. I wonder what the issue is. I'm going to do a fast one in here and just add the status label to the arguments. That's definitely going to throw an error later on. So let's run this and see. We're getting an error message. So the first error is telling us, we don't want to run it in here. If we run it in here, we're running in that's right, in the virtual environment. So we don't want to run in the virtual environment. We want to run it outside. But looks like the first error we're getting is because our start game function, is actually holding our root main loop, so we can't find it, as well as the button. So we need to indent it out. So indentation is key. Remember, Python doesn't have curly braces, so we have to make sure we pay close attention to our indentation. Let's clean this up and run it again and see what we got. We still got another error message telling us about TCL was not installed properly. So let's test this out clearly. And I believe the issue here, is about the virtual environment. So we can't be running it in the virtual environment. So let's run it outside. And you see we have a modern looking GUI, but the widgets are overlaying each other. As you expand it, you can see it clearly. So let's fix that real quick. The button should be on row 5. Let's run it again. There you go. So as you can see, we need to check our geometry. Let's make it wider. 600 still does not cut it. So 750, again 750 would be the width. Yeah, I have to write this out so I don't get myself confused. The width by the height. So yes, that looks a lot better. Okay, so again, this looks modern, a lot better, a lot more elegant than the previous one. So we select easy, we click on the start game, and we get to choose or guess the letters. And we get an error message. Ooh, this looks like a problem with the lambda function on line 19. So yep, we go to line 19. We actually did this intentionally when we added the status label in our make guess. It should not have been there. We just needed to get the status label indented outside the start game. So run it again, select medium, guess a letter, and what letter do we want? Oh, looks like it's showing up. Good. So we can keep guessing and guessing some good letters, and eventually we get to Spider-Man. Yay, congratulations, we won. Let's try it one more time. And I mean, the user interface is appealing. User experience is not that bad. We can keep building up on this. And this time around we guessed Captain America, and we're good. But as you can see, when we start a new game, Captain America was quite long, so we need to work on that bug. But for now, everything looks good. We can clean it up. And like I said, the issue we had earlier was due to the virtual environment. So let's recreate it. Let's reproduce that. So from the command line, we can see that we have Avengers game folder. Within the Avengers game folder, we created a virtual environment to segregate our packages from everything else so that there's no conflicts. So now let's go ahead and activate this virtual environment. The virtual environment is just going to have everything of ours in a container separate from everything else on the system. So now we activated it. You can see Avengers_VNV in parentheses. That shows you're in that virtual environment. So let's change to the folder that we have our program in and execute it. And for sure, we have that error message. That's because we are executing it from the virtual environment. So let's deactivate this virtual environment. So to deactivate the virtual environment, very similar to activating it, we go into the folder, the scripts folder, and deactivate it. So you don't have that anymore, and you can run the code without any issues. So now that we have our modern looking code, let's package it up and share it with others. Again, portability. Think about DevOps. We want to be able to build and set it up. So before doing that, let's check the packages we have. So it looks like we already have, along with Customtkinter, we already have PyInstaller. So if we try installing it with pip install PyInstaller, it will tell us that the requirement already is satisfied. So that's fine. So with that, we can just go ahead and use our command to package the file. So PyInstaller one file will create just one file. No console will make sure that when we run the file, nothing shows up on the console. But we have a typo, an extra space. So let's get rid of that extra space and run it again. And as you can see, our PyInstaller is doing its magic. So what exactly does PyInstaller do? In a nutshell, it's actually just going to check for all the dependencies that we have for our code, checks the code too for, making sure that it's correct. So it builds everything together, but before building, it does the analysis, inspects the code, checks the dependencies, tracks them, bundles everything together in a collection, including Python interpreter libraries that are used, the ones that were downloaded like Customtkinter, everything that was imported in our Python modules, including our version 2 file. If we have any other data files, images, configurations, and so on, all of those are packaged together to create, in this case, one executable file. And then, understanding the folder structure and so on and so forth. It does a little bit of code optimization, compression, all that fun stuff before we actually get our final code. So as you can see, it's speeding out the output. Quite a lot has to be done. And at the end of the day, we should have one file which just popped up. It's less than 30 megabytes. So what we will need to do then is just share this file, distribute it with anyone. So it goes into the distribution folder, and the build folder has a lot of other dependencies. So let's go ahead and wait for it to complete. As you can see on our command line, it's still running. So let's be patient with it a little bit. Okay, so there are a lot of benefits. Again, easy distribution, it's a standalone executable, it's improved portability, and you can deploy it very simply. So let's go ahead and copy that and paste it somewhere on our desktop. Once it's pasted on our desktop, let's go onto the desktop and check it out. Obviously it's still loading up because you cannot see the icon. Once the icon pops up, then you understand that it's done copying and pasting. So let's exercise some patience while we are liking and commenting and subscribing to my channel. Yes, so please do go ahead and like this video, comment, subscribe to our channel, and you can see, voila, good things happen when you do that. So we can test our application. This time we're running it directly from the desktop, putting in all those fun letters and characters, and you can see you can run it as many times as possible. So drop me a message on the comments if you like to have a copy of this or a copy of any other program that you like me to package or set up or walk through, and you should be good. Awesome. So using the same logic, let's build a web app using Flask. And since we've done this a few times, I'm just going to have some beautiful music. But first, let me tell you in a nutshell, we're going to import the necessary libraries: Flask for creating the web app, render template for rendering the HTML templates, request for accessing the data with HTTP requests, and a couple of functions from our module that is version 2. And then we jump into creating the Flask app, initializing the Flask application, assigning it as app, defining a few routes. Okay, the first route usually, handles the initial page load. In this case, it's the index function, which renders the index.html template. We have a couple more routes. The start game, which actually routes and handles the start game button click. Okay, so it receives the difficulty level from the post request, generates a random word, and calculates the number of guesses based on difficulty. And finally, you have the make guess route, which actually handles the guess button click. This time around, it receives the current word, the user's guess, and a list of previous guesses from the post request. So updates to the game states are done, the guesses, the word display states, the messages, checks for win and lose conditions. That's about it. So in order for us to be able to get this to work on a web page, we need some kind of HTML. That's where the templates come in, because all our functions are rendering templates. So we create a templates folder, make sure it's in the right location, and it's plural, templates. Within our folder, we have an index.html file. Quickly run through that again. I have a whole full tutorial on front-end web development, and also another tutorial with Flask web apps, where you can see how rendering is done using Ginger templating, and so on and so forth. So I'm gonna run through this. If you have any questions, drop me a comment, and I will do my best to clarify it. I love those comments, so keep them coming. And again, we have a couple of templates we're going to work on, the index.html and the game.html, which are all being routed from the app.py server-side logic within our functions. So enjoy the coding session, and I'll be back to round up with a better version of this code, which is going to look more appealing. So let's get on with the first, making sure that we get the handling of the user interactions, difficulty selection, guest input, button clicks, adding all the Ginger templating, capturing all our inputs and variables so that we can get this to work first, and then we add all the bells and whistles. So let's go on. Okay, so it looks like everything is looking good. Let's go save all our files, go into the terminal and run our Flask app, our Flask web app. So once we run it, it pops up, gives us those instructions. We can follow the link and there you go. That's what it looks like. We select the difficulty level, enter a letter and it crashes. Yikes. Okay, so there's an issue with the return statement for the make guess function. So let's go to the make guess function and the return statement is on line 55. So again, you'll notice that with Python, most of the time, if it's not a syntax error, it's usually an indentation error. So let's collapse everything nicely and try to identify, debug, troubleshoot where our issue is, and voila, on line 55 we need to indent the return to be outside the scope of the if statement, and then we should be good. So let's save this. Once it's saved, we can kill this test server that's running, close the pages that were running earlier, and then we can go back and start the server again with one Flask. Follow the link and check it out. Run it, enter a value. Yes, there is an A and we can see our letters and our words are being formed, and that's a WASP. So, looks good, but you notice that there is a bug and the initial letter is not displayed once we land on our page. So we need to fix that bug in the next enhancement. Alright, so let's enhance our web app, beefing up the styling and the images. So again, it's just a typical web app. We've cleaned a lot of things up. We have templates and static files and a virtual environment as well. So let's go into our terminal and make sure that we're not using PowerShell. We go into the command prompt itself and we're within the virtual environment. So in the virtual environment, all we have to do is Flask run, and it's going to deploy, or rather open up the development server. And there you go, it looks splendid. We have a space for us to output our word, and we have a guess history. We also get a feedback on if our guess is good or bad. We have an input box which accepts just one letter, and so on and so forth. So everything looks really splendid. There's a navigation bar at the top. We have a welcome message. We have an image. We have cards and all these nice colors which actually enhance the user experience. And again, this is not a finished product. We still have some kinks in here and there that we need to fix, as you'll see when we go through all of it. So this looks splendid. Alright, but how do we accomplish this? I'm going to walk you through the entire process. So if you lose, you get a different message, you get a different picture, but you can try again. So one of the bugs, as you'll notice, is when we try again, we do not reset our word. That's just a simple fix. We just need to make sure we get another random word rather than get the same old word that we're doing. So in this case, we easily win because we know what the word was. Alright, so that's how you go ahead and do that. So let's walk through the code real quick. Very similar to what we have before. This time around, we use a random within our app because we are not importing modular code. Again, we have the index, the process guess, as well as the start game functions, which do pretty much the same thing we've talked about before. Okay, for debugging purposes, I print out some of the outputs for sanity check. Again, this is just for the staging environment. When you go live, you need to get all of these comments and debugging and code out. So yep, reset game as well. We added that, which is where we just need to make sure that we get a new random word each time we're resetting the game. And that's about it. So very similar to everything we've looked at, but in this case also we have templates, and the templates using base templating, and we have 3 different HTML templates: index, game, and results. So in our base template, we have everything that makes it look uniform. The title, we have a link that makes our page beautiful because we get Bootstrap. And to get that Bootstrap, we actually just download it from Bootwatch, select a particular theme, whichever one you like. So in this case, I selected the sketchy theme. It looks good for our purposes. On here, whatever component you need, you can get the CSS styling from there, like this alert indication. You copy the code, and any of those different components can also be used. The cards, the containers, the navigation, as you see at the top, or just download the entire CSS and you should be good to go. So yeah, that takes care of the styling. Also, we add a fev icon, which is what you actually see at the top of the tab. Let me show you what it looks like. Yep, the Avengers icon, and you see it right there at the top of your tab. It makes it look neat and easy to identify if you have a lot of tabs open. Also, we need JavaScript to be able to handle the button clicks, like the drop down, lets you be able to choose a difficulty level. We haven't implemented that, but that's something for a new feature you can always add and, improve or enhance your game for the next version. So navigation, again, you go in and copy the entire code. It goes into our base template so that navigation is uniform across the board. You have the same uniform header, which also has a welcome message, an image, an Avengers image, Marvel Avengers image, which reminds you of what game you're playing. And then the block contents, which is then filled up by the particular template, be it index. As you can see, the index extends the base and then fills up the entire block with its own content. Its content is going to have like the number of guesses, the name of the Avenger, the word display, and some small space for you to enter your, right here, the space for you to enter your input, and a button to click. That button will take you now to the game page. The game page also extends the base template. A game page actually has 3 sections. 3 columns. The left column shows you the guess history, so it keeps track of what are the good guesses and the bad guesses. The right column shows you a message, whether it's good or bad guess, and the middle section is actually holding a lot of fields. Most of them are hidden. What you see is just your input field, and that's about it. At the end of the day, if you won, I get to display the Marvel image with all the heroes. And if you lost, you get to see the Doomsday image, which is coming up in the movie. Yay! So that's it for our web Flask version. So let's run it one more time and see what our results are. Alright, so everything is still on our development server on our machine. So next up, we want to deploy it so that everyone in this world can access it publicly. In that case, we're going to need render. We're going to choose to deploy it using render. Again, watch our other video. We have about 20 or 19 other options for you. So on render, you can see I already deployed a static web page and also deployed a Python 3 Flask app. So let's check out the Flask app. This is what it looks like. We worked on this before. Check out the front end and back end web playlist on my channel. Subscribe please, and like, comment on the video. Just to check out a few of the settings, you'll notice that the repository is coming from GitHub, and we specify the root directory. Everything looks good. And you want to also make sure that if you have any environmental variables, you pass them in, and so on and so forth. So that was really straightforward. In this case, we're going to not do it in a production environment. We're going to create our service in a staging environment. You can create as many environments as you want, but we just have those two tied in with our GitHub. You know, we authenticate ourselves, select the particular repository or repo that we want to access. We don't need all of it. We just select a particular one that we need. We have our project going in there anyway. So select that repo and connect to it. And it's always a good idea to give it a unique name. Otherwise, it's just going to append one to your previous name. So choose your service, Python obviously. Since we're using a test or free version, it's just going to throw us to Oregon. And I'm not going to take chances with the path. So I'm going to go to the actual path of my repo and copy it and paste that path of my root directory to my file. So as you can see here, a few things we need a requirement text. So requirement is just a list of all your packages. So to get a list of your packages, you go into your virtual environment and do a pip freeze. The pip freeze command is going to print out all the packages that you need for that program to run. So we're going to output it to the requirements.txt file and make sure the spelling is correct. And that creates that file with the output on there. So now we can use our source control. The new file that has been created needs to be saved on our local environment or our local machine and also pushed to the remote machine. We don't need to sync it because there's nothing on the remote end that we're pulling down. So once that is good, we now have our build command, which is going to pull all those packages and build them together. And the start command, I think, yeah, let's go ahead and make sure everything else is good. We still have the required fields, so let's make sure that's, make sure this also is accepting GUnicorn. And we're using the free tier for hobby projects. And everything looks good. Once we save it, it's going to automatically build and deploy. So it depends on, the time of the day and the server's speed and what its burden is. But again, it's going to speed out everything to the URL that it's giving us. We could have changed it at the start, but that's a good lesson to learn. So we'll save that in there for now. We'll come back to it later. As you see, it took all 8 seconds to completely build our package. Now it's deploying it. And while it's deploying it, let's go check out the others. You can see the others are already deployed and ours is showing it's currently deploying. So making sure everything looks good. Yeah, it's a little bit too late, but let's still go ahead and change the name of our service so that it's actually unique and descriptive enough for us to know what service it is. So let's save that and then go back and check on what is going on with our deployment. Oops, our deployment failed. So it's not a big deal. We go into the settings and check why the deployment failed. We need to go ahead and actually go into the deployment by clicking on that link. There you go. And from there, you can actually check the log files. So check the deployment logs. The previous one was okay. The first deploy still failed. So within the logs is where you always find the right answer. So here, the GUnicorn command was not found. That means I need a GUnicorn. Again, GUnicorn is the web WSGI, web server gateway interface. I can never get it right. Yeah, so again, it sits between the WSGI and your actual application server. So it's simple. We just do a pip install. Now GUnicorn is in there. We need to update our requirements text so that it's also in the dependencies. Once we go ahead, our command line pooped on us. That's okay. We'll open a new terminal and do that. So within a new terminal again, we can go ahead and do a pip freeze and point it to the requirements.txt file. And now you can see in the green section, we have packaging and GUnicorn added in there. So go ahead and commit and push. So committing is like saving your file locally, and then pushing is making sure that Git sends it to GitHub. And now we can go ahead and deploy the latest commit. So again, this has to do with DevOps. It helps us to really automate the process. It speeds up, streamlines. We have everything standardized. I mean, it's really a breeze. You can imagine having to do this in the past would take a long time. But, you can make simple changes to your code. Make sure you give some descriptive commit comments so that when you come back to it, you can always revert to an older version, which works. So let's see how this is going to work around this time. We've had a couple errors. We have another error. So going back into the deployment to see what the issue is. Looks like our settings are off. So let's check out the settings in the previous one that deployed successfully. That was our Flask app. You will notice in our start command, we should have GUnicorn should be looking at the app. I don't think we have app in the current version. We probably have your app. We just have a placeholder. So we need to go in there and fix that. Yep, it says your application. So GUnicorn should be executing on app. There you go. So let's save our changes. And I don't think there's anything else that needs to be changed. Our link is still stubbornly the one that they created for us. That's what we get for using a free version. But it works for now. And I think this time around our deployment should be successful. But again, these are all good areas for us to learn. And once you document this nicely and in your absence, anyone else can replicate this. So documentation is key when it comes to development and software, not just software administration in general. So we're done building. Everything is successful. Deployment is going on. While the deployment is taking place, I encourage you to subscribe and like this video. And just like I said, our deployment is successful once you like and comment on my video. There you go. So let's test it out. If we go in there and run it, remember it's a free server, so everything is going to be really slow. It's not going to be instantaneous. So let's give it a second to pull itself together. Once that happens, and again, if you haven't subscribed yet or if you haven't liked the video, now might be a good time. As soon as you like it, everything is going to start running smoothly, right? All right. So again, using that free version, and just like I said, it is running smoothly, and you can go in there and play around with it. Oops, I lied. Curse of the commentator. All right. So it should be working smoothly now. Yes. A is in there and there's a space in there, and that's giving me a bad feeling. The space did not show up, so I'm having a feeling that we have a problem here, but let's carry on. So it's a man And from all indications, it would probably be Speedy, should be Spider-Man. But my space is not working and I'm losing my head, so I'm just going to fail us through this. Let's get some really bad letters. Like, again, the space did not go. W will not work, Q will not work, and we failed. So it's a dash. Now, this is a good opportunity for us to make updates to our code and then we deploy it. So if we come in here, our Avengers list, Spider-Man should have a dash, which means Ant-Man should have a dash. Again, that's not the right way of doing it, but for our code, we were accepting dash spaces and not dashes. So write that awesome comment in your commit message, otherwise it will not commit, and then push it, save and push, or commit and push. And once that's done, we need to redeploy it. So that it's as easy as that to deploy your code online because of the continuous integration, continuous deployment, CI/CD pipeline, which automates, shared responsibility between the development and the operations team and everything else we talked about in the previous videos. I encourage you to check them out once again. So this should be a quick fix, the build and the deployment should go smoothly, and then we can go ahead and test our application again. We should be good. So like I pointed out, please test thoroughly, read the documentations, and you should be good to go. So that's about it. Just from scratch, we started very gently and humbly with our console app, built it, tested it, it looked good. We modularized our console app. After modularizing it, we used that same modular code in our GUI, which we then packaged and can share it with anyone that like to play our Avengers Assemble word game. And then now we just concluded the web version, using a lightweight Flask framework for Python web applications. After setting it up, testing it on the development server on our computer, we can also deploy it online and anyone can follow that link and play around with our app just like that. So, see how much fun Python is? There's a lot more of fun applications we're going to work on. So subscribe to the channel, smash that like button, and that's going to encourage me to keep working harder and sharing all this fun stuff with you. And it's also going to help others who are like you that enjoy this content to be able to find it on YouTube. Alright, so catch you on the next video. We're going to talk about a few more fun, not just Avengers, there's going to be other fun Avengers projects and other projects. But if you have any special requests, please drop me a comment, discussion. I'm very, very eager to play around with your ideas and come up with something fun. Alright, just like you already know, it is Vitusdk at your service.